In today's lesson, we're going to be using Pythagorean's theorem to solve equations when we're trying to figure out the lengths of the sides of right triangles. So if we look at this example, we have a right triangle with the legs being 3x and 4x and the hypotenuse, which is radical 200. So remember Pythagorean's theorem, a squared plus b squared equals c squared. My legs are 3x and 4x. Now remember, when I plug these in, I'm going to plug them in parentheses. 4x and 3x. It doesn't matter. 3x and 4x, 4x and 3x. The order doesn't matter with addition. And the square root of 200 squared. Quantity 4x squared. Remember, I'm squaring everything inside the parentheses. So that means I'm squaring the 4 and the x. So that's 16x squared. 3x quantity squared is 3 squared, which is 9, and x squared, which is x squared. Square root of 200 square. That's the inverse operation of each other. So the square and the square root cancel each other out. So you're just left with 200. Combine like terms. 16x squared plus 9x squared, these are like terms, you can combine them, is 25x squared equals 200. Divide both sides by 25. So we get x squared equals 8. All right, 200 divided by 25 is 8. Do they say around these? Let's see. No, we're just going to estimate. So both sides, square root of 8, which is about, I shouldn't say equals because it's not a perfect square, 2.8. Now again, if I wanted to simplify it, the square root of 8, that breaks down to 4 and 2, 2 and 2, 3 branches. I'm going to pull out the pair, which is a 2, and then there's one branch left over that stays inside the radical. So 2 radical 2 is the simplified radical version at least. So you could have 2 of these possible answers. All right, let's look at another one. And we got our legs here, 5x and 7x. Got our hypotenuse, which is 2 radical 74. So we're going to do 5x quantity squared plus 7x quantity squared equals, and again, this one in parentheses, 2 square root of 74 squared. Remember, I'm squaring everything inside the parentheses, so the 5 and the x. So that's 25x squared. Same thing here, 7 and the x, which is 49x squared. Square the 2. When you square 2, that's 4. When you square root of 74, those cancel each other. So this is 4 times 74. Remember, the square and the square root cancel. But you still have to square the 2 on the outside, and you're multiplying those. So, combine like terms, 25 plus 49, I should have 74. I know that off the top of my head. I don't know why I did that. 74x squared 4 times 74. Well, actually, it's 296. All right. Divide both sides by 74. And you get x squared is 4. Divide both sides by 2. No, square root. What am I talking about? Square, opposite of square is square root. So we have my x is exactly a perfect square, which is 2. Now, one thing I forgot to do in the last problem, you have to put it in, plug it in to figure out the length of the side. So 7 times 2 is 14. 5 times 2 is 10. Double check our work. We could do 10 squared plus 14 squared is 296, which is this number right here. Look at that. So let me go back to the other problem, plug in those for the sides. So 2 radical 2. Or you could do, you know what? Yep, I'm glad we simplified it. Did it say solve for x? Let's see. Oh, it just says solve for x. Oh, I didn't find the missing side. All right, so we're going to find the missing side. So let's plug this back in. 4 times 2. You only multiply the numbers out in front. So instead of x, it's going to be 2 radical 2. So 4 times 2 is 8 radical 2, right? Because you just multiply those two numbers out in front. If I multiply this one over here, 3 times 2 is 6. Radical 2 stays on the inside. So those are the lengths of my legs. So once you solve for x, make sure it's not, the problem's not done. Find the lengths of the legs just using multiplication. You multiply the number outside of the radicand. So that's it for today's video. If you have questions in class, please let me know. Thank you for watching.